Assalamu alaikum wa rahmatullah, and welcome to our matric revision session. Today we're focusing on mathematics, paper 2, and we're looking at geometry with our special guest tutor, Sandra Dixon, who joins me online once again. Sandra, good morning and welcome.
Good morning. Righto, I'm going to sort of just get away, okay?
Fantastic. And also, just a note to you, if you're watching us on YouTube or Facebook, these videos will remain up. People have asked the question, well, why are you doing it in the morning? Kids are at school. Well, these sessions remain up online. Please do like the channels and share the videos. They'll remain up online, so you can go back and check them out. And, of course, also, this is an opportunity for you. If you're not a matriculant, but you know someone who can benefit from it, let them know about these sessions. Well, without further delay, Sandra, I'm going to hand over to you for today's lesson.
Thank you. Good morning, guys. Today I'm going to continue with paper 2, the November 2020 paper, and I'm going to do geometry. And what I'm doing towards the end of this session is I'm going to go over the proofs that you need to know as far as geometry is concerned. So maybe for those that watch this video from the beginning and you are okay with the problems that I'm going to be doing, turn towards the end of the video where I go over the proofs. That is the stuff that you need to learn off by heart. So I'm explaining them, hopefully making it a little bit easier for you to remember it. So let's get right in. Question 8 of the 2020 November paper 2. We have a picture, a geometry picture on the right-hand side. O is the center of the circle. Now, very, very, very important. There are various keywords at the top of these questions, and they point you to the theorems that you may be using when you answer the question. So if they tell you there's a center of a circle, I will immediately go and look if there's a diameter. Now this one does not have a diameter, so we won't go any further, but we at least know there must be radii because it's the center of the circle. And our radii would be OK, OP, and ON. So just if we discuss introduction to the question, if you look at OKP, that would be an isosceles triangle because of the radii OK and OP. So we just keep that in the back of our mind. They tell us KOM. Let me point at it. KOM bisects chord LN. So here we've got a theorem. And this theorem is, if the line through the middle of a circle bisects the chord, the angle is 90 degrees. So M2 and M1 are 90-degree angles. Then they tell us MNO is 26. K and P are points on the circle, and NKP is 32. So now, what I find you guys do is you start everywhere except where the question is pointing to. So they give you that this angle, MNO, is 26, and that NKP is 32. That means you've got to start with either those two angles. So let's look at what does the first A section want. They want the size of O2. So let's play real dumb and we decide to start at 26. And I normally jokingly or mockingly say, you must find a mate for 26. And you can see 26 is like very lonely around here. It's not pointing anywhere to get something, another 26. So if that doesn't work, we go to the other side and we look at 32. And we need to find another angle that's equal to 32, because this is where we start. So the basic thing that you need to do, and look very carefully, look at P and N. That forms a chord that's not joined. So normally what you do, if you have an angle like that, you follow the angle's lines back to the circumference of the circle, and you will get to PN, which is a chord. And then typically what you would do, so we then in English say K1 stands on chord PN. Then we look for another angle that's maybe subtended by PN. And we go up like I'm showing you here, and we see it is O2. And we should remember that this makes a theorem. So in the answer, I said O2 equals 2 times K1. So that is the theorem that says the angle at the middle is twice the angle at the circumference. And please note the wording that you use here. The school would have given you a paper where the wording, the exact wording that you need to use is actually written out. So please don't write all sorts of other things. There's more than one way of writing it, but please stick to the type of jargon that they want when they mark your paper. So now we fill in. We've got the 2, and we take the 2 there, and we look, K1 is 32. So it's 2 times 32. So O2 would be 64. And we put the 64 over there. So that's the A part of it. Let's look at the B part. Now in the B part, we want O1. So let's take that 52 away. So we want O1. So now we need to look. We've already used the 32, but this 26 we haven't used. So we would be looking at that next. But we also keep in mind that they told us that this chord is bisected. So now I've added in, because you basically, it flows like a little story. So from the 26, now we want to do some sort of a calculation with that angle. So we see that M2 is 90. We saw that long ago, but we need to write it down. And the other tip I'm giving you guys, if you cannot find a solution, at least write down all the theorems that you do see in the picture. Maybe you will just get a mark for it. So if we saw that M2 is 90, we would write it down. And the bisecting line through the center. So the part that's important here is it's about that line through the center. So the bisecting line through the center is perpendicular to the chord. That's why M2 is 90. So the next thing you do, if you see a triangle and you have two angles, because now we have M2, which is 90, and the other one that's 26. We always try to fill it up so we can calculate O3. So O3, we will complete the sum of the triangles in this triangle here, OMN, triangle OMN. And we will use that theorem and we will say 180 minus 90 minus the 26. And the reason why we're using this is the sum of the angles in a triangle equals to 180. And if we do that in the calculator, we will get 64 for an answer. So O1 is 64. Now O3, sorry. O3 is 64. Because I'm trying to be smart here, not to put all the stuff in at once, because that makes the explaining a little bit more difficult. So now we have O3. Now, why do we want O3? So first of all, if you didn't see why we wanted O3 from the outset, we basically just did, we saw that's 90, and we saw we could calculate O3. But KOM is a straight line, and O1 is part of that straight line. So if we use the straight line theorem, we can now say O1 equals 180 minus the 64 minus the other 64, and O1 will end up being 52. And the reason is it's a straight line. So let's put the 52 where it should be. So now we've done all of that. So we've answered question B. 8.1.2. Now they want to know, prove giving reasons that Kn, and I've put it into red so that you can see, bisects, that means cut it into half, into 2 equal pieces, bisects OKP. So to conclude, what do we want to show? We want to show that K1 is equal to K2. So in other words, if K1 is 31, 32, K2 has to be 32 as well. So how are we going to do this? Now we have a weird little triangle here. And this sort of a question is in every paper. This is your isosceles triangle, because you get OK is equal to ON. And then there's a little formula that we can use to calculate K2. So let's see, how did I do it? So I started off by saying OK equals ON, and that's radii. Then I calculated K2, because K2 is equal to angle ONK, because it's an isosceles triangle. But you're not allowed to write isosceles triangle anymore. You have to write equal sides, equal angles, meaning the OK and the ON are equal sides, so the angles at the base of it are equal. So now we use our sum of the angles in a triangle theorem again, and we would say 180 minus the 52 plus the 64. So if we've gone up to there, we would get K2 and ONK, but they are equal, and we only want one of them. That's why we divide by 2. So the answer is 32. And remember, always end with what they've asked. So therefore, Kn bisects angle OKP. So please take note of this one. Let's see, I wanted to put this in here for you guys to see where your equal sides are. See, there's the radii. Sorry that I'm doing it a little bit on the late side. But there's your radii. And what I was talking about is these are the 2 angles. That's equal. So here we have our equal sides, equal angles theorem. Okay, so I'm just sort of pausing a second so that you guys can have a look. And why I'm sort of stressing it, you will not find a paper at the end of the year which doesn't have this type of a question in it. It's hidden pretty well, but they are always testing whether you can find an isosceles triangle and whether you can apply the little formula that I'm pointing to there now. So 8.2. Now we are working with something that hasn't got much written there. So let's see what they're asking. In triangle ABC, that's the big triangle, F and G are points on sides AB and AC, AB and AC. D is a point on GC, so that angle D1, and they marked it, is equal to angle B. Okay? Now, some of you mistake this with a midpoint theorem. It is only the midpoint theorem if I clearly tell you that AF is equal to FB. That sort of a thing. And then we need some parallel lines as well. So please, when they say it's like a point on a side, it has to be the midpoint to be the midpoint theorem. So F1, so now to prove this one, let's see what we need to prove. If AF is a tangent to circle passing through points F, G, and D. Now, I normally, if I have a pen and paper, I use my pencil and I color the sides or the vertices of something that they call a circle. Because drawing a circle around it normally looks like an egg and it confuses you more than actually putting little dots or circles where the circle is. So AF is a tangent, is passing through F, G, and D. So we now need to prove with reasons that FG is parallel to BC. So immediately if you see the parallel sign, you need to think about FUN, F-U-N, your corresponding angles, your alternate angles, and your co-interior angles. So when you see that in any question, it must immediately ring a bell of the theorems associated with this. And they said tangent. So the theorem around this tangent, because they're not telling you tangent here, it's loaded, okay? So it's got to do with the theorem. So they're actually telling you something here. So let's look if we can't find a tan chord. So if AF is the tangent, FG is a chord on this circle. So if we then can prove or find a way to say that F1 is either equal to B or to D, then we almost have the question done. So let's see how I went about writing it down. So we start with the theorem that they've given us, the hint that they've given us, and we would start with F1, and that is equal to D, angle D1. And that is your tan chord, and the chord is the chord FG. I'm just putting that there so that you guys know which chord I'm talking about. And D1 is equal to angle B. They've told us that's equal. So now important, have a look at what we've written, the 4 angles over here. Can you see that the D1 repeats? So if it repeats, it means they're equal. And you can deduct from that that F1 must be equal to B. So this is what they call deductive reasoning. So that is why it's sometimes difficult to visualize this before you've written it down. So we can now conclude that angle F1 is equal to angle B. F1 is equal to angle B. And they are also corresponding angles. Okay, they're equal and they happen to be corresponding angles. So because they are equal, we can now say that FG must be parallel to BC because they make up corresponding angles. So this is like a reverse theorem, and the way you would go about it or think about it is that you need to, when they ask you to prove FG parallel to BC, you make a plan. And the plan is that we see corresponding angles. Then we prove that they're equal because those lines are not parallel in the beginning. So you cannot say they are corresponding angles unless you can prove that they're equal. And we've proven that they're equal, therefore those lines are parallel, and the plan that you made were corresponding angles. So I hope you see more or less, because I'm trying my best to explain to you how you must think about this type of a problem. Now we're still with the same problem here. Now it is further given that AF to FB, that's a ratio, is 2 to 5. AC is 2x minus 6, and GC is x plus 9, the way I've put it onto the picture here. Now, you should have known from the previous question, the 8.2.1, that if there's a triangle and you have parallel lines, we've just proven that those lines are parallel. If you have that, we are working with proportionality. We are working with a proportionality theorem. So you need to recognize that. So let's see, let's apply this theorem here. So AB, I call that the long one, AB to FB, a shorter one. If those lines are parallel, they are in proportion to AC, a long one, and GC, a short one. So you need to see how to use this theorem, and we are actually led by what they've given us. Can you see they gave us the long side and a short side? That's why we do the same on the other side. And then we just fill in. AB is 7 because we add the 2 and the 5 together. And FB is 5, equal to AC, which they've given as 2x minus 6, and GC that they've given as x plus 9. Now we have a little equation. We cross multiply because there's an equal sign there. That's the only time you do cross multiplication, if there's an equal sign. So we do 5 times 2x minus 6. And on the right-hand side, we do 7 times x plus 9. So basically, we are getting rid of the fraction at the top. You also could have done it by using an LCD. You will get the same answer. Then we multiply out the brackets. So it would be 5 times 2x is 10x. 5 times negative 6 is negative 30. Equals 7 times x is 7x. 7 times 9 is 63. Then we put the x's to the left because there's no squares or anything there. X's to the left, numbers to the right, and x is 31. And very important, when you use the ratio at the top, please remember to write the reason, your proportionality theorem, comma, FG parallel to BC, because that's a mark that you guys also throw away because you fall away and you write just this ratio down, but you never write down where you got it from. So very, very, very important. Remember to write this proportionality theorem down when you do this type of a proof. Right, so I just did 2 questions from the paper. The one was just a plain Euclidean and the other one was proportionality. Then I thought it fit to actually go over a couple of theorems, the ones that you need to learn. I've looked at all the past papers. This one is the jackpot. They ask it like every 2nd or 3rd year. They would ask you guys to prove this theorem. And it's 5 marks. You have to study it off by heart and and reproduce it in a very specific way. So let's see. In the diagram, O is the center of the circle. Points S, T, and R lie on the circle. And then we have got chords over there. QS, here at the bottom, is a tangent to the circle. Use the diagram to prove the theorem that states that angle QST, I've numbered it a 1, is equal to the angle at R, which is R1. Now again, on your paper, you won't have the red. So to prove this theorem, you will have to do a construction. So we're going to construct the diameter from S through O right up to K on the circumference. And now comes something that actually caught me out as well a couple of years back. Now you don't know whether you should connect this one, the K and the T, or the K and the R. Because what they do is sometimes they ask you to prove that this one, S1, is equal to R1, or if the tangent goes longer, they may ask you to prove that the angle that I'm pointing at now and T is actually the same. So you need to be very careful to know how you do this construction, otherwise you chuck your points, your marks away. So both of them has got a line through the middle. Now you can see this forms a 90-degree angle. The theorem is radius tangent. So your radius is always perpendicular to a tangent. So that's a 90-degree. And this theorem hinges along 90-degree angles. So when you study it, now you need to remember you need another 90-degree angle. And the only way you can get it is by connecting K and R, because now you will have an angle in a semicircle with diameter QS. So R1 and 2 is also 90 degrees. So can you see the 90 degrees that you make are on the opposite sides of the diameter? That's how you check whether you connect it properly. So let's go through it. So S1 plus S2 is 90, which I already pointed out. The reason is radius perpendicular to a tangent. Now we go to our other 90-degree angle. So R1 plus R2 is also 90. Angle in a semicircle. Now we can say, and this is the crux of this thing, S2 is equal to R2. Right, I'm going slowly. R2 is subtended by chord KT. Can you see? R2 is standing on KT. So is S2. S2 is also standing on KT. So therefore, these two angles are subtended by the same chord, so they are equal. So that is why I wrote S2 is equal to R2, subtended by chord TK. Now this we miss and then we lose our marks. So now if we have a look, same as with the previous question, we have a S1 plus a S2 equals 90, a R1 plus a R2 equals 90. But now we saw that S2 is equal to R2. So those two are equal. We've got two 90s here. Therefore, we can derive that S1 must be equal to R1. And S1 is the QST that they asked us to do. And R1 is what they asked us to prove. So we can conclude by saying angle QST is equal to angle R. So this is 5 marks. which we can easily mess up because we look at this theorem and we think, we know how to do it. Please, please, please write it down at least once or twice before next Monday when you write this paper, so that you get this 5 marks, all 5 marks. Now the next one is in a diagram JKLM, which is a cyclic quad, and the circle center O, prove the theorem that angle J plus angle L is 180. Now, the sum of the angles in a quadrilateral is 360. So therefore, if we prove that 2 opposite ones are 180, the other 2 has to be 180 as well. So we only need to prove it one way. So if you need to prove the J and the L, we connect, we basically halve the picture if you study it and you want to remember it. So we connect KO, radius KO, and radius OM. So that's the construction that we make. So now we actually made ourselves another theorem here. So O1 would be twice angle J, because the angle at the center is twice the angle at the circumference. And angle O2, which is the big one on the outside, the obtuse one, is equal twice angle L. Again, angle at the center of a circle is twice the angle at the circumference. And now we do some algebra here. So we say, we add O1 and O2 from up top. And because we add those two, we can add the 2J and the 2L on the right-hand side. Now, O1 and O2 is 360 because it's a revolution. It goes right around. And we factorize this 2J plus 2L. So 2 open bracket J plus L, common factor. And we want J and L alone. So the 2 doesn't belong there. It's multiplied here, so they divide it on the other side. The 360 over 2 equals J plus L. And therefore, J plus L equals 180 degrees. Right, so we've done what they asked for. We've proven that J plus L equals 180. So this one is not difficult, but again, there's some learning to do because you need to know to set up this. And you need to know that O1 goes with J and O2 goes with L. Don't swap them around because you will lose marks. Now, this one is also not difficult, and I think pay a lot of attention to this theorem. Prove that the angle at the center is twice the angle at the circumference. So in other words, that angle COB is twice angle B. Again, we must make a construction. So we will construct BOK, and K is on the circumference on the other side. Then we number our angles to make life easy because we're interested in COB. Oh, yes, something not right. Yes, CO. It should say COA. COA. Is twice CBA. So the angles that we're interested in is O1, O2, which I numbered, and that you put in your answer book. So please make sure that the constructions and the stuff that you write in is part of your answer. And B1 and B2, we number it like that. Now we start off by saying O1, because just let's go back. OB and OC are radii. We have our famous isosceles triangle again. So angle B1 is equal to angle C. So we will say O1 is equal to C1 plus B1 because O1 is an external angle to triangle COB. You see, one side is extended, and that forms an external angle. So that's the, apart from the isosceles triangle, this external angle is equal to the sum of the opposite interior angles, is a very important theorem. Make sure you know it because it will be in your questions. Right, so I've said O1 is equal to B1 plus angle C. But C, angle C, is also equal to angle B1, which I've explained a minute ago. Reason being, it's an isosceles triangle. You're not allowed to write that anymore. So you must write CO equals OB, comma, radii in this case, which in effect is equal sides, equal angles. So now we look at what we wrote. If angle C and angle B is equal, we can basically replace them with twice angle B1. Plain algebra. Similarly, we can do it from the other side. We can say O2, where I'm pointing now, is equal to twice angle B2. If we now add it up like with the previous theorems, O1 plus O2 equals 2B plus 2B2. We factorize again. 2 open bracket B1 plus B2 close bracket. And then O1 plus O2 is actually angle COA. COA equals twice angle B, because B1 plus B2 gives angle B. So please, they haven't asked this one for a long time. So maybe make sure that you really know how to do this one. Okay, so I'm going to conclude now for today. Thank you for listening, and I hope all goes well on Friday. I hope you found benefit from the previous videos that I made, and that you also have a good time with paper 2 on Monday. Bye-bye.
Sandra, I want to say a big thank you to you for joining us and making a significant contribution, I think, to the empowerment of students as far as maths is concerned. I know many people have enjoyed the session, and we look forward to, in future, hopefully, continue to engage on the world of maths. I think that you've demystified a lot of this paper. All the best, and stay safe.
Bye-bye.
Bye. Well, that's it for our matric revision session for today. We focused on geometry, and that, of course, with Sandra Dixon. If you would like to get a hold of her, it's Sandra Dixon 67 at gmail.com. She's a tutor with a BSc in mathematics. She does grade 8 to grade 12. The right person for you to contact if you are looking to upskill yourself in terms of maths and preparing yourself for exams. Well, from myself, Mohammed Fasih Peterson, I speak again, inshallah. I bid you assalamu alaikum wa rahmatullah. Do be advised, these lessons do stay up on Facebook and YouTube, so you can go back and check them out. Like and subscribe to both the VOC Facebook page as well as the YouTube page. And in addition to that, share these videos with others. That's how we can help each other improve and benefit and yeah, hopefully get better marks in the exams. Well, wassalamu alaikum wa rahmatullahi wa barakatuh.